For today, we're reviewing higher degree polynomials. Tomorrow is mostly going to be about placements. I'm going to talk to you about what class options you have and then give you each an individualized placement for next year. And then you might be like, well, what about the rationals? Rationals, which is something that we practice a little bit on the board here, that is going to come in a video, which will play for you, the sub will play for you on Monday of next week. That's really the only day you'll miss me. And I'm recording a video specifically about rationals for that day. And you can do some more practice on that worksheet. And then the actual final is the only other time you'll miss me. And the teacher will hand it out to you. It'll be a math teacher who can actually, understands math. If you ask a question, they'll know what you're talking about. And that's the only 2 days you'll miss me out of the 4. And that makes it a very good, efficient use of all of my comp days and personal days and stuff. All right, so here we go. What are the possible roots of this thing? Do you remember this deal? You put a plus and minus in front of it. And then you take the factors of the top, this one, and they go on top. That's the constant. Well, there's only one thing that can multiply to make a 7, and that's 1 and 7. So that's two different numbers, 1 and 7. And then you take the factors of the lead coefficient, which is a 1 and a 2, and now you got to know what to do with them. You divide everything by 1 and you divide everything by 2. So then, to kind of clean this up and get a final answer for it, you have a plus and a minus again, and you take this and divide it by 1, which makes 1. Take this and divide it by 1, and that makes 7. And you take this 1 again and you divide it by 2, and that makes 1/2. And then you take the 7 and you divide it by 2, and that makes 7/2. And there are all your possible roots. And yes, there are 4 of them if you just count them like normal numbers. And then there's negative of all of them. That makes 8. There's 8 possible roots, and that's a pain in the butt. When the actual problem comes, there will be one on the final, where you have to try to figure out which of those 8 actually work. You'll probably use synthetic. All right, so let's go on to number 2, because that's that way. Now, it doesn't tell us what the possible roots are here. It doesn't say that, x equals 2 is a root. Or it doesn't say a factor, like x plus 1 is a factor. It doesn't say that. But this happens to be one where you can factor by grouping. Do you remember doing that? Everybody do the factor by grouping thing on problem 2. Hint, if you don't know how to start, these should be grouped together, and you go, oh, x squared can factor out of that. See if you can finish it from there. Leah Martin, after x squared came out, what did you have left at the beginning there? X plus 1. And then what did you factor out of these next two? 2. And what did you have left? And look at that. We've got a common factor again. So that goes to the front. Most common mistake right now is to square that. No. When you factor something out, you don't square it. When we factored out that 2, we didn't square it. Okay, so you factor that out, and then what's left is after, it's kind of like you divided both of these by x plus 1. And it just kind of cancels those out. And then what's left is the x squared plus 2. Can that be factored? No, not unless you use imaginaries. So that brings up this point. There's real answers, and that's easy. -1 is your real solution. I could just call it x equals -1. I'd be fine with, since you know that's an x-intercept, so the y is 0. You could have said -1 comma 0. Either of those is fine. And then the imaginary solutions. Set this equal to 0 and solve. But here's the most common mistake right now. You get x squared equals -2. You square root it, and you think you're done right there. You are not. It's absolute value of x, which then leads you to 2 answers. And you got to remember that square root of -2 is really I root 2. And then, because there's an absolute value here, there's going to be two answers, plus and minus I root 2. So those are the imaginary solutions. I'm going to zoom this, or having trouble seeing it, or what? All right. So that's just a typical one where we had to factor by grouping, but what if it won't factor by grouping? Well, this one doesn't need to factor by grouping. You'd start by factoring out just the x. You factor out the x, and then it'll be easier to factor. Let's go on to the next page. They get harder, of course. So on this page, is this a factor by grouping one? Can you make two groups? Yeah, that'll factor by grouping. That'll be easy. How about this one, number 7? Factor by grouping? No. Be careful. There's an x squared and everything, so factor out x squared. No, factor out 2x squared. All right. Let's just finish number 7. Everybody factor out the 2x squared. Will, can you shut that door over there, please? Thank you very much. Seems to be happy noises, but still distracting. Double checking myself. I always start with the x's. I always think about what signs should I use. And I used a plus and a minus because I needed to get a negative number there. And then 8 really only had 2 choices, 8 and 1 or 4 and 2. Pretty sure I picked the right one. Now, I see lots of real solutions. You know how I can tell there isn't any imaginary ones? Because I can just get a clean, nice, easy answer for each of these. -1 makes it 0. 8 makes it 0. And 0 makes it 0. If I had tried to solve one that said x squared minus 8, that is not going to be so clean, and I'd have to watch and try to figure out, would that have negative answers in the square root? No, that would not. I could solve this one. X squared minus 8 is equal to 0, and then x squared equals 8, and that's not a problem. It's when it's like this that you'll get imaginaries. When you set that thing equal to 0, that kind, then you end up having to square root a negative. That's what it always comes down to. If you find yourself square rooting a negative, that was an imaginary one. This one, number 7, does not have any imaginary ones. It's just got real roots, which means they are x-intercepts. All right, to this page. Is it just more and more of the same thing? No, eventually we get to the kind where you can only do it with either long division or synthetic. Let's do number 10 because that will be one of the hardest things on the final. Do you remember how to do synthetic division and how to interpret it? First mistake you could make is putting a 4 right here in the little box. What should it be? -4. You use the 0 for this. Okay, the thing that makes it 0. And then the next mistake you could make is not looking for missing terms. 5, 4, 3, 2, 1. There is a missing term at the end. Do you get that there's no just constant? And that means you should start by factoring something out. Or you could put a +0 to hold the place. But I personally like the idea. Do you get they all have an x in them? Every single one of them has an x in them. I'd factor that x out at the very beginning. And then all your numbers will be easier. Because now it's not x to the 5th anymore, it's x to the 4th. Plus 8x to the 3rd. Plus 14x to the 2nd. Minus 16x minus 32. And now it doesn't need any placeholders. But it's really common for a kid to factor out the x and then forget that that's there at the very beginning. It's the first factor was an x. So then I'm going to use these numbers, 1, 8, 14, negative 16, negative 32. Drop it like it's hot. Technically, you're adding 1 to 0, and you get 1. And then you multiply. Then you add. Then you multiply. Then you add. Then you multiply. Positive 8. Then you add. Then you multiply. And I ended up with a 0. That's a good sign. I always put an R there. It's not required, but that reminds me that's the remainder. And then this part factors to an x plus 4. They told me that at the beginning, right there. And this part, I start with my constant. I make this one have an x on it. I make this one have a x squared on it. And I make the 1 there have an x to the third on it. Very common mistake right now is to just copy that in and feel like I'm done. Do you get, I should look and see if it factors again, and it does. This part right here factors by grouping. Anytime you got 4 parts, look for that. Okay. Almost, well, it's the last thing on this page. Determine the degree, the leading coefficient, and the end behavior. All right. So on this kind, it's pretty easy. You just got to make sure you don't get trapped into thinking that the first number is always the lead. That one's the lead because it's got the biggest degree. So there's your degree. The leading coefficient is that. And the end behavior comes from that. And you go, I would start on the right. You don't have to. But I like to start on the right because I see the negative there. That means it's down. And since it's even, the left is the same. Good. Okay, this one is really important that you know how to find the lead term, and it's not this. That's not the lead term. Take a second, figure out the lead term, because then that'll tell you the degree, the leading coefficient, and the end behavior. So find the lead term. Y equals, it's got a whole bunch of x's. It's not just x to the second. Do you agree the x part is x to the 5th? I'm going to highlight where I got that from. X to the second, that makes x to the 3rd. That would have made x to the 4th, but it's squared, so that makes it x to the 5th. Now how about the number in the front? It is definitely not the -2 because there's also this 3 squared, which is 9. 9 times -2 is -18. If you didn't catch where I got that from, it came from this number and that number squared. So there's my lead term, and it tells me the degree. It tells me that it's going to go down on the right, and since the degree's odd, it must be the other way on the left, and I think that's enough review of that. And last but not least is this page. So they've given me equations, and I'm supposed to be able to write the, they give me graphs, and I'm supposed to be able to write the equations. Let's do the top one and see if that is enough to help you with that kind. That's at -1. That's at 1. So the factored form for this thing, the first thing I did is looked there. See how it's going down on the right? It has to start with a negative. So easy to forget that. Then I need a factor for each of my roots. I got one for -1, so that's going to be x plus 1. And the other one's +1, so that's going to be an x minus 1. Is there a bounce going on at either one of those? Yes, there's a bounce right there. So you square the one that has a root of -1, which would be that one. Would you guys agree that looks a little fishy, like it might be an inflection point? I agree. I'm going to say that's an inflection point. And therefore, it's degree what? 3. If it was just passing through, it would have been degree 1. Now I look back and make sure I didn't mess anything up. Okay, this one would have a lead term, if I did it right, of negative x to the 5th. Are my ends going opposite directions from that 5? Yes, they are. Is the negative in front taking care of the going down on the right? Yes, it is. So my lead term here of y equals that seems to be working. It's probably right. And that'll tell you the degree, 5. Oh, increasing and decreasing intervals. Holy cow, whole nother topic. All right, look at this. Would you agree that on this graph, it is sometimes increasing, but it's generally decreasing? The only place it's increasing is maybe the most interesting place. Right there, it's increasing for a little bit. So, what is that from? Well, we have to trust these little tick marks here, that's at negative 1. And I'm going to say that it stops increasing right there at 0, just because it's so much easier if I say that. So then it was increasing only between negative 1 and 0. If you put brackets here, I wouldn't mark it wrong, but the standard way to do it is parentheses. And how about decreasing? Well, from 0 on, it decreases. From 0 to infinity, this thing is decreasing. I know it kind of like hitches for a second right there, but we have to assume, unless that's actually a flat spot on the graph, I think it's an inflection point there, so that means it's decreasing that whole time. This is a bad enough graph that we wouldn't have been able to use it on the final. It's not clear. If this was actually going flat for a while, then I couldn't say it was decreasing in there, but it's not. It's supposed to be a curve. All right. Yes?
So, what would look for the roots?
I would kind of assuming you'd know that, but I'll go over here. You tell me, what were the roots?
Negative 1
Yep.
and 1.
Yep, but if I just write this, do you think Mr. Server would like that? No. You better say what they are. You could either say x equals, which is what I'm going to do, or you could have put them in points. Because they're x-intercepts, the y would be 0. So you could say 1 comma 0. Yes?
Would it be decreasing from negative 80 to negative 1?
I did not finish the increasing and decreasing. I had a whole bunch of hands all of a sudden on the other stuff. So I'm not done with the increasing and decreasing. Yes? Okay, on increasing and decreasing intervals, I'll repeat what I said about brackets and parentheses. I would accept brackets, but when you're doing an increasing interval, the standard thing is to put parentheses on it. But I get how you could argue, like, at the top, is it still increasing at that exact moment? I mean, that's kind of a esoteric, like, I don't know, so I would accept brackets. But parentheses are the standard way to write intervals. Okay. So, degree. I never actually answered degree. It came from here, and it was 5. So, and if you guys want me to finish. Increasing, there was only one increasing interval, but there were multiple decreasing intervals. So let's finish the last decreasing interval. And that would be from negative infinity until it hits there. So from negative infinity until negative 1. If you get confused on the increasing and decreasing intervals, these are all x values. The increasing and decreasing numbers are only x values. So like on this next one, if I said this part is where it's decreasing, I care about there to there. It's like, where did it start decreasing on the x, and what x value did it stop decreasing? So in this case, it'd be 0 to 1, 2, 3. Looks to me like that's 4 marks over. So between 0 and 4, it is decreasing. And again, I would be okay with brackets, but I think parentheses are the standard way to write those. Okay, we're almost done. Last topic on the whole chapter is, if they tell you a bunch of stuff about this, you have to be able to like write an equation in completely factored form and then find the imaginary solutions. Oh my gosh. Well, it tells me that this and this are roots of it. That means I can factor them out. As soon as they tell me that those are roots, then that means there's a factor of x minus 2. You'd be able to do this with long division if you wanted to, or with synthetic. So if I decide to use synthetic, I'll say, okay, I'm going to take that 2 out, and I'm going to do synthetic on this, and it's going to be a 1 for that first number. And then, wait a minute, there's no x to the fifths. There's no x to the fourths. There's no x to the thirds. There's negative 13x to the seconds. There's no x to the firsts. And then there's a negative 12. See all the placeholders I had to put there? That'll help you to factor it. And I just did the one with the 2. And then, when you got the answer that's left, you can do another synthetic and use negative 2 on it. But that was really a tricky one. Honestly, feels too hard for the final to me. All right, what are the roots of this? Well, they're just the x-intercepts. That's super easy. And you could sketch the graph of it. We've made it to the end of this. Now, there is one more unit, and it's rationals, but you're not going to get that until I record the video for it. I'll do that sometime on probably Friday, and then I'll post it, and then I'll get that to the subs so that on Monday you watch that review video. And then you have been completely refreshed on everything that could be on the final. All right. That's all I got for you for today.